Actually, CloudQuery already supports more resources and APIs than AWS config, just because they're dealing with the same problem of how to support the enormous and kind of infinite number of APIs that is just growing and, handling all their nuances and then transforming it and normalizing into a database.
You are listening to the Kubelist Podcast, a show interviewing project maintainers for open source projects with a focus on CNCF sandbox, incubating, and graduated projects. Hi, I'm Marc Campbell. Together with Benjie DeGroot, we publish the Kubelist newsletter dedicated to Kubernetes and the CNCF ecosystem. I'm the founder and CTO at Replicated, where we enable software vendors such as HashiCorp, Puppet, Harness, and many others to operationalize and scale the distribution of their modern on-prem software. Check us out at replicated.com. Benjie is the co-founder and CEO at Shipyard, where they enable teams of all sizes to build, test, and deploy faster and more reliably via their ephemeral environment management platform. Get started with ephemeral environments at shipyard.build. The Kubelist Podcast is brought to you by Heavybit, the leading investor in developer-first startups. For more information, visit heavybit.com. If you're interested in being a guest on this show, or you would like to suggest a project, find us on Twitter at ReadKubelist. Finally, sign up for the Kubelist newsletter and read previous issues at kubelist.com. On this episode, Yevgeny begins by describing his background in the Israeli military and how he got into cybersecurity space. Then he transitions to talk about the origins of the CloudQuery project and what the project does. CloudQuery is open source, and Yevgeny shares his thoughts on why it's open source, and then also his current thoughts on creating a commercial offering without hurting that open source project. We then dig into how the project works, use cases for CloudQuery, specifically around security and compliance, and the hard problems, that this is solving as to why you shouldn't build this yourself. Of course, Yevgeny shares what they're currently working on and the direction of the project towards the end of the episode. Enjoy. Hi, welcome back to another episode of the Kubelist Podcast. As you just heard, we have Yevgeny Pats, CEO and co-founder at CloudQuery, ready to talk about the CloudQuery open source project. And of course, Benjie's here too. Hey, Benjie, how's everything going?
Everything's good. Turbulent times, but doing pretty well.
Great. So let's dive right in. Yevgeny, we'd love to start off hearing a little bit about your background. Will you tell us a little bit about your career and what led you to creating CloudQuery?
Yeah, sure. So first, thanks, Marc and Benjie, for hosting me. Really excited to be here. And we'll be happy to tell a little bit about myself. So last 12 years, I'm focused a lot on entrepreneurship, cybersecurity. I started my career at the Cybersecurity Intelligence Unit 12 years ago. Been there for 4.5 years. And after that, kind of started my startup journey. Joined a first small enterprise security startup back in 2013. It was pretty quickly acquired by Checkpoint. And then I figured I wanted to start my own startup, and also went into enterprise security for a few years. But then pretty quickly, I understood that I'm too young to run the company with get a demo button. So I kind of forked, and last 5 years, I was focused solely on the developer space and a lot of product-led growth, a lot of open source projects. And before CloudQuery, I ran continuous fuzzing as a service project called Fuzzit. It was partially open source, but mostly focused on our first clients were open source projects, and it was acquired by GitLab in 2020. So I've been there for a while, learned a lot from the GitLab remote culture, and kind of then started CloudQuery as an open source project, which I can dig deeper into why I started and so on. But I think that's a high level overview, and maybe in one sentence before I dig deeper into CloudQuery. CloudQuery is an open source project. It started as an open source cloud asset inventory. So if you can think about it as Terraform, but just the other way around, we connect to all the cloud infrastructure APIs, AWS, GCP, Azure, extract all the configuration, transform it, and load it into Postgres database, into structured tables. And then DevOps engineers, security engineers, site reliability teams use us for a variety of use cases, starting from visibility to security, compliance, monitoring.
That's great. There's about 35 things you just said that we're going to probably want to hear more about.
Yeah.
But I just want to go back to the beginning for a second. You mentioned early on in your career you were in the cybersecurity space. I'm not sure if you're allowed to talk about exactly what you were doing or where you were doing it. But can you tell us a little bit more about your early career and what you were doing?
Yeah, sure. So I guess my passion to like computer science started kind of like in high school probably, or in school. And then,
sorry. So where did you grow up, Yevgeny?
So I grew up in Israel, in Haifa, it's the north. My parents actually came from Russia back in the 90s. I also like immigrated, but I was 6 months old.
Ah.
So yeah, I'm kind of like in Israel. I just like have a bit of Russian accent for some reason.
Yeah,
to me.
It's weird to keep an accent from 6 months, but it makes sense.
Yeah, I couldn't fix it, but yeah.
No, I mean, so look, there's obviously a trend especially in CNCF, but in general about some really amazing Israeli companies coming out. And I think it's interesting to talk about how that education system over there kind of led to this. And then obviously there's the mandatory military service that it seems like that played a role in your career and your trajectory as well. I think it'll be really interesting to understand whatever you can share about that with us.
Yeah. So I think also like probably like if you ask like 5 entrepreneurs from the cybersecurity unit, everyone will have like a different opinion on like how it like came out to have this nice ecosystem, but probably like it's because of different variables. But I think one thing is like the thing when you go to the army in Israel, it's a mandatory service. And then like some of the units like, or like the best units or the best unit out there, like the technical one, they have like the ability to choose. So they're trying to choose the smartest people that they can. Like, of course, there are also like other places with smart people. Not saying that, but essentially like they can choose. So basically they bring everyone together. So it's like a great place to learn from a lot of other smart engineers and also get like the ability to work on interesting things like early on in your career. So I think this really, provided a great kind of place for everyone to learn and then, to go out there and build interesting stuff. And other than that, I think there is also like macro economics, like a lot of funding as well in Israel. So, combining those two together, I think brought some interesting or good outcomes.
Well, one thing I think is really interesting about the whole Israel, the tech ecosystem, is that you get these kids that are obviously very talented, but you didn't have a lot of experience when you're 18, at least from a professional perspective, I would guess. And I think it really creates this very creative environment where, and I can't remember who told me this, but an Israeli friend told me that you guys kind of go into these very elite units and you guys don't know what you can't do. So you guys kind of just do pretty close to impossible stuff. And it seems like it creates and fosters it's kind of like a startup mentality. Is that a good way to look at that? Or what do you think? Yeah,
I think it's a good way to look at it. And I think there is also like some truth to that. But I also think that, and like, I don't want to ruin the marketing for the Israeli entrepreneur, but there is also like the other, like the chicken and egg thing, right? That, I think even if like there weren't like cybersecurity intelligence unit, like potentially outcome would be like similar because, you take smart people in and then you get smart people out. Like there is a lot of like good stuff happening in the between, but, I think smart engineers would be also like fine, even like without it, right? So it's not just because of that, like it's definitely like helps and creates some interesting ecosystem and bonds and so on. But yeah.
So let's move on and let's chat about the product for a little bit. Like you defined it as a cloud asset inventory. So the way you described it sounds to me like I have Terraform or Pulumi or some other tool. Maybe I'm just using the AWS console and like not following any kind of modern best practices, but I have all my cloud infrastructure. And then you have a service that's querying what's available in all the infrastructure that I've created in the cloud, inserting it into a structured schema'd Postgres database that I can then have anybody on the team query to know what's out there in the cloud. Is that what CloudQuery does?
Yeah, exactly. And we also connect like not only like depending on your infrastructure, also to other things like Okta, Cloudflare, like anything else in your infrastructure that you want, like to slice and dice or, create, like get visibility across clouds and so on. But yeah, that's exactly it. And like, I don't know if your next question is like with regards to Terraform, right? Is if everything is in Terraform, right? Why do I need to go again and to get the information if I already have it in Terraform?
I mean, the question has gone through my mind. So like,
yeah, so I think definitely like that's the kind of like the best case scenario. Yeah, if you got to a place like where everything is in Terraform, basically like a grep probably would do fine for any kind of like visibility questions. But the issue is like in medium companies, big companies, like not everything is in Terraform. So you actually want to have this kind of to have like a view of what you have, and maybe also compare with like what is defined with Terraform, which is, I can also talk a little bit about like how we are doing that. But yeah, basically that's the best case scenario, but that's usually not the real world scenario.
Yeah. And I think that it's also fair, just keeping in mind that like Terraform is a declarative system that defines what's going to run in the cloud provider. But there are things like autoscaling groups and like, manage node groups for EKS, things like this that actually mean that you don't know, you're defining the criteria for the cloud provider to run. I'm assuming in that scenario, CloudQuery is able to actually tell me like what's actually running at this moment in the cloud.
Yeah, exactly. That gives you the current snapshot.
Great.
Right. And errant clicks are is a reality for all of us in the infrastructure space and the AWS console. So let me ask you this question. So you take all this information and you kind of give it a unification, if you will, because obviously Okta is, maybe not covered under your Terraform or your Pulumi. So that's really cool. But then you decided to put it into SQL to make it a SQL accessible. Can you tell us a little bit about that decision and why a modern enterprise would want to enable their internal teams for SQL?
Yeah, so like we started with SQL, but essentially the biggest problem here, like you can look at it at this problem in general more as a data problem. So the issue usually is to get all the information from those APIs, like normalize them and put them somewhere, like in a structured way. So yeah, we started with kind of the vanilla Postgres. But something that we saw that users do, and also we plan to support like other databases, they take this structured information and then they load it into any other place if they want to do like a different set of analysis or connect it to their like current monitoring or visualization platforms like Grafana or Superset or like whatever they have. So yeah, like went with Postgres SQL just because it's kind of the standard way to go, the first way to go.
How do these different connectors provide? I'm looking at your website. It looks like you call them providers, right? For AWS, for Azure, for Okta, et cetera. Like, how many of these do you have? And like, how active is the community around like creating new ones? Or one kind of last way to look at that is, if I want to run CloudQuery, but I have something that's not supported, can I just run it? Or do I need to make a contribution upstream in order to get that provider in?
Yeah, so actually some of our users like make contribution and we approve them pretty quickly, but you can also, compile your own provider and run it. Mm-hmm. So you don't necessarily need to wait for it to be upstream, though we are relatively fast, at least for now. So that's the whole idea, because like the main problem or the main challenge here. So let's say, even if we go in and look into things like AWS config, right, which is like the enterprise or the commercial competitor from the cloud provider, or Google Cloud Asset Inventory. So you will see that they have there are a couple of disadvantages there. Like one, they usually use kind of a custom query language, so you don't have access to the raw data. And second, even though they are in AWS, they don't support all the AWS APIs or GCP APIs. So actually, like CloudQuery already supports more resources and APIs than AWS config, just because they're dealing with the same problem of how to support the enormous and kind of infinite number of APIs that is just growing, and handling all their nuances and then transforming it and normalizing into like a database. And this is some of the challenges also the Terraform has in dealing with kind of providing this abstraction layer on top of cloud APIs.
Right. So that makes sense. And I can think of like all these different use cases. Like, let's go all the way back to the beginning though. Like getting data out of the cloud provider, making it available so that I can use, a Postgres query, join things like this, super powerful. Like, what was the use case you originally were building for?
Yeah. So the first use case that I was looking was especially around security. And specifically, I was looking at enterprise products like CSPM, like Cloud Security Posture Manager, from, either like big companies or startups, like companies like Palo Alto Networks, Checkpoint, or other kind of next gen enterprise startup. And what was mind boggling for me is like, one, why there are so many of those. And two, like they actually like all building or all implementing in-house, like at least probably 80% of their time or development time, they're implementing this kind of a closed source ETL engine. And then just probably 20% of the time building like the rules or like the security value that they sell, right? So actually it's a data problem. So what we started to build in CloudQuery is trying to rebuild the whole stack, either it's for security use cases or compliance or cost use cases, rebuilding it on top of CloudQuery as a data app and building CloudQuery as a like data ingestion platform. And like being open source, also giving the ability for like users or developers write new integrations, commit and contribute to our official integrations, and not being blocked by a vendor that can't really maintain like infinite amount of APIs and integrations.
So if I'm an enterprise customer and I'm a CISO, or maybe I'm someone under a CISO, and I want to know from a compliance standpoint, what are all the assets that I have? Where are they? What are they doing? What is the configuration around those? CloudQuery is really where.
Yeah. So you can run all your compliance policies with SQL. You can create views, like generic views with all your cloud assets, query them across regions, query them over time, create alerts when something is not according to your company policy, and you can use a standard like query language to create any rule you want.
Have you seen customers or folks using CloudQuery to query the data and then using an external policy engine like Caverno or Open Policy Agent or something like this, and then CloudQuery is like critical to provide the data as the context for the external policy engines to make their decisions?
Yeah, so it's a good question. And what we saw with regards to OPA and SQL, so people who use CloudQuery, they use SQL to write their like rules, join across tables and create their security or compliance or cost rules, and then they create other kind of standard alerts with their workflows, either it's Grafana or anything else. And with regards to OPA, like OPA is really good language like for in-memory processing for things like Terraform or Kubernetes, but actually running OPA on top of like all your cloud infrastructure, it won't be a great fit because it will probably just run out of memory, or you will need a very big machine. So I think this is like exactly where actually you need a database. Yeah, probably there is no better solution than like some kind of database, either it's Postgres or something else. But like we saw companies load like 10,000s of accounts and millions of resources into Postgres. There is no workaround having a database here in that case. Sure.
So let's talk more about policies then. So CloudQuery, how could I? They completely make sense to me that like you have this service, and we'll talk about where it runs, how it runs, and everything. We'll get into some technical details, but like I end up having a Postgres database that has everything that's in my AWS account or my Cloudflare account, Okta. What is your best recommendation, your best practice to like define policies that can run either regularly or continuously? And I can use these, in evidence for, like potential like compliance auditors or customer reports and things like this.
Yeah. So the best, like our suggested way is, so one is to look at our like pre-made policies. We have a bunch of them on our website. We have something called CloudQuery Hub with both providers and policies. And like we made those policies for like CIS benchmarks and all kind of like the standard industry standard compliance and security policies. So the policies are actually just list of SQL queries in an HCL file, and CloudQuery knows to parse them and just like run them one by one and produce a result. So you can run them in a CI and a GitHub action on like daily basis or whatever schedule you want, and then create your like alerts and events on top of it. So yeah, we have kind of a very simple HCL format file, which basically just group together a bunch of SQL queries, which define your policy. And you can put them in the Git. So you have all this compliance and security as code thing.
Let's switch for a second here. I think I'm curious. CloudQuery is an open source project, but there's a company behind it. There's a commercial entity. Do you have a commercial offering on top of it? Do you have plans to? Can you help me understand a little bit about how you're able to continue just to work full time on an open source project?
Yeah. So currently we're working from VC funding, right? But the idea eventually is to have a managed version. So right now our customers deploy CloudQuery with, so we provide Terraform and Helm charts. So they like deploy it and it runs periodically on their infrastructure. They maintain also the database. So yeah, it's self-hosted right now, but the idea eventually is to have a managed version where people won't need to maintain their own infrastructure. So like that will be the first step, right? I don't know like what features exactly, or if we'll have like features that we'll have only in the commercial product and not in the open source one. So because it's a bit farther down the road, but yeah, the plan right now is really to continue focus on the open source adoption. So we had like great adoption in the last like 6 months to a year from big companies, from Fastly to Autodesk to Tempus, and like we want to continue like growing this list of great users and supporting the current one until we are sure like we hit the kind of the critical mass where it will make sense to start also like putting money into developing the managed version, right? Because like if you have too little users and you fork too early to a managed version, then you will end up with very little users on your managed version, and it will be turned to be very expensive users.
Yeah.
I mean, that's an interesting topic though, because if I'm using CloudQuery, I probably don't want to have that data not on my servers, because it's kind of a weird dichotomy there a little bit, right? Like what if I don't mean to be critical. I'm just saying like, so if I'm using the managed version, that means that my data is going to live on your servers, basically, that tells the whole compliance story for my organization.
Yeah. So it's a fair feedback and like a good question. And I don't know all the answers to that, but we do know, like from the customers that we talk to, yeah, some of them probably will never buy our managed version, but some of them actually like said that, like their whole policy is to use managed wherever possible, just because like infrastructure burden is real, and they try to avoid it. And there is also somewhere in between, and this we'll be able only to understand when like we'll be there, like how good or how bad the conversion rate, and like do we need to come up with kind of smarter solutions to make people more comfortable to migrate to our managed one, either it's things like maybe hosting the database somewhere in their cloud or not. Like maybe it won't be a problem, right? Because we know it's not a problem for some of our customers, but we don't know like the conversion yet, right?
Well, to be the devil's advocate to my own point, I also think that there's a third-party audit component that is really interesting, where CloudQuery is SOC 2 compliant, all the ISO 27 million, whatever it is.
Only thousands right now.
Oh, we're only in the thousands right now. But yeah, having that, and then of course there's the obvious I can say, because it's not my company, there's options to help you with on-prem versions such as replicated. Sorry, Mark, but I can shill for you every once in a while, right? This all makes a whole lot of sense. It's just a lot to think about. And honestly, when we get into the compliance world, we're all going through it, and it's very interesting, and it's a really, really, really interesting topic.
But I think I hear one of the big takeaways is that like there's going to be a commercial offering, but you don't want to cannibalize or hurt the open source tool right now. So you're not in any rush to figure that out. When it makes sense, you're going to have it. But like the open source version is here to stay, and like you're committed to supporting that right now.
Yeah. So I think this is exactly it. And we are actually I'm actually speaking from a painful lesson. So when we just started it, I open sourced it first, even before the seed round, it took off relatively quickly. We started to get good traction from big companies and decided to double down on that. And our first thought was, oh, okay, great. Let's also start the managed version. Let's try to monetize quickly. And then turned out to be 4 or 5 months of half of the team of very expensive experiment. Then we understood that it's not feasible to do both at this early stage, because it's a complex project, and you need to work both a lot on the engineering to solve a lot of hard engineering problems, and also to work a lot with the community and the adoption to understand what you need to develop. So the project really has to be mature enough until you release Pwn to the managed version. And yeah, it will take time. So now from startup and money perspective, you should be as lean as possible until you get the project to this level, right? Because you also because it will take a lot of time to monetize. Apart from maybe some support agreement, you want to be what we're trying to be as lean as possible until we are sure we got it, and now we want to split and put more effort into the managed version, which we know will be very expensive.
I think it's really interesting, and it's a good lesson, and that we've seen a lot of projects fall on their face, falling into that trap, and we've seen some other ones kind of go to the path that you're talking about and be unbelievably successful. So it's a good lesson. And again, our audience is kind of very interested in the whole open source ecosystem. So it's a great way to think about how to build a company around an open source project and just all the different gives and takes of it. So I have a question, not to actually not talk about compliance or VC stuff, but what is CloudQuery implemented in, and kind of tell us about how development works and all that stuff.
Yeah, so it's written in Go. So the first reason for that was apart from that a lot of new projects are written in Go, is really the distribution thing. So it's compiled to one binary. So that's really eases up with distribution. Other than that, it's really good language. It has downsides, especially for some things. But I think in general, for something like an ETL, pluggable ETL framework, it's worked pretty good for us. And a little bit about the architecture. The architecture is actually really similar to Terraform, because we used a lot of their underlying libraries like Go plugin. So because we wanted to create a pluggable architecture, so we have CloudQuery, which is one binary, and then we have our official plugins for AWS or GCP, which are a separate binary and are hosted on our CloudQuery hub. So CloudQuery downloads the plugins that you want to use and then runs them via gRPC via this pretty widely used, I would say, HashiCorp library, the Go plugin. So I think they did a good job there, and I think it's the best project probably out there around basically loading plugins in runtime. So
yeah, that's great to be able to to find that and model the architecture after it, because years ago that was a hard problem to solve in Go, and being able to stand on the shoulders, if you will, and just be able to say, oh, great. Like this is a provable pattern. And it's got some maturity behind it now. We can actually like write code in Go, which is what we want to write code in for all the benefits that we like. But now we can like, it's just the open source community, right? And being able to reuse that library and packaging and follow that pattern.
Yeah, that helped us a lot because it was a really tough problem. It got much easier with this library, and like even this library is like when you use it, like it's quite complex. The very good things is it's battle tested, and it works. You just need to read the documentation very well and understand how it works when you kind of like touch those pieces of code. But it saved us months of development, if not years.
Yeah.
Yeah, and probably some pain down the line too. You probably are saving yourself on a whole lot of pain for some weird edge case that you guys didn't have, as they say.
Yeah.
Hey, does anyone know if kubectl uses it for their plugin stuff? Does it use that? Do we know?
I actually don't know the implementation of that, but kubectl is just like separate binaries that have to be on the path for like the crew style plugins.
Right, but they're extending the plugin. Everyone's using plugins now for kubectl, I think.
Yeah.
Which is my most important question, Yevgeny, and we'll get back to other stuff. But kubectl or kube control? What is your answer?
I think kube control for me. Actually, I didn't know the other one.
No. Oh my God. All right, Mark. Okay. The interview's over. All right, we're done. We're good. I'm a big kubectl guy. I'm a big believer in kubectl. So I tend to ask everyone that question. But
I get it. Okay, I wasn't aware that like this is how you pronounce it. Okay.
No, I'm on a mission. Okay, I don't think there actually is a right answer per se. It's Emacs versus Vin type world, or tabs versus spaces. But okay, so going back to the actual implementation, what is the hardest problem that you guys have kind of tackled so far? Was it the plugin architecture, or is there something else that's really challenging that you guys have dealt with?
Yeah, that's a great question. I think the hardest problem is around like how to support and maintain a huge amount of APIs. And I think like also in the data world, like projects, I think like Heavybit that integrate with big amount of APIs, and also project like Terraform, they have like similar challenges and different solutions to that. So I think like this is like the biggest challenge, and like also the biggest engineering challenge. And I can talk about this a little bit. And probably like maybe you saw also in Hacker News like a few months ago, like on Terraform, that like they stopped accepting community contributions for a while. I don't know if it's back. And like if you go to the issues, like the number of issues is huge. Like either it's because of like an underlying API or Terraform API. So this is the biggest challenge, right? Because for CloudQuery to be very useful, it has to integrate with a lot of like APIs, both inside one cloud and also like across clouds and other SaaS services. And you want to do that like also fast, like because new APIs are introduced. And also you want to do that with a small team, right? Because otherwise you will have like a very large cost, and we're not making any money yet, right? So we want to be as lean as possible also when we will be making money, right? So that's like the engineering challenge. And like to talk a little bit more about just the engineering challenge, it's like at scale here is like, how do you maintain that also? And how do you test it? So a lot of our solutions were around code generation and trying to write tools that auto-generate that, like both some of our like integrations and also some of the tests. And this is like where we invest a lot, so we can scale more easier, catch more bugs in development, and stay as small as possible while supporting as many as possible APIs. And I can talk about like some of the code generation like issues that we tackled.
Yeah, like I mean, I'd love to hear some stories there around that. Like, how did you, like adding one or two in, probably not the hardest problem in the world to go figure out how to query EC2 data and write it in. But like when you actually get into both many of them and keeping them updated, that's when you're just really, really, really relying on automation to make the product reliable and up to date for everybody. Like, I'd love to hear more about how you did that.
Yeah, exactly. Like that's, I think, like a great point. When you just do like an EC2, people are like, oh, okay, just like running that. But when you start to like supporting hundreds or thousands of AWS APIs, the amount of issues that from also like people that use it, like this API is like not returning what I think it should, or like how do you catch as much bugs as possible early on? Otherwise you will be also like bombarded with support requests. So maybe before like I talk about the code generation, actually in this specific world of providing abstraction on top of cloud APIs, so it's like a well-known problem in like the Terraform, Pulumi world, data world, and actually AWS also like they are aware of that their API is not unified and it's hard to generate code for it. So they actually introduced AWS Cloud Control API about like 6 or maybe 7 months ago, which is like an API specifically for tools like cloud security posture management, Terraform, Pulumi, so they can auto-generate their whole integration on top of this API, like unified API endpoint. It's still very early on and it doesn't support like all their APIs and so on, but I think it's a step in the right direction from like AWS side. Yeah, and on our end, like we provide a lot of tooling around generating our plugins from AWS non-unified APIs. So like that's one part. And the second part is also like generating the tests. So we have a lot of like mock tests, and we also have end-to-end tests with real infrastructure. So we try really like to test as much as possible, because otherwise you will really be bombarded with support and like small annoying like bug fixes. Oh, this like small field is not populated into the database.
Right.
I mean, and there are a lot of changes that happen on all these. There's a lot of surface area on the things that you guys integrate with. So I can imagine quite a few headaches. So, I mean, that brings up a good point though. If I wanted to add something, I don't have your hub in front of me right now. What do I want to add? I want to add Linode. I like Linode. I used to like Linode. I still like Linode. And I want to do this, and I want to do the community thing. Would you guys add a Linode, actual infrastructure for the end-to-end tests? And how can people contribute? How can people take part in this? I guess is kind of my question.
Yeah. So there are actually some community providers. So we just market, like you upload it to our CloudQuery hub, but we just mark it as community provider. And then it's like up to you to manage and maintain it. Like we maintain as much providers as we can, and we plan to like write more when some of our tooling will improve, so we'll be able to support more. But yeah, like for example, Yandex provider is a community provider. They maintain it. So like the third party cloud provider maintain it. But also we saw like other people write their own provider for, let's say, Datadog, because they wanted to extract more configuration. So they maintain it.
How big is the team right now? How many people are working full time on CloudQuery?
So we are around 12 people, mostly engineering. I would say around 8 people working on the open source project, and 3 more people working on all our web-facing assets. So CloudQuery Hub, all our documentation, like both the CloudQuery docs and also like the provider docs, which is like all the schemas, all the tables, our policies. So like it's a lot of work there. So we have a team just for that. And then also like product and security engineer, like for, customer support and kind of educating our customers, writing content, tutorials. Like we found it to be super helpful for current users and new users.
I mean, it's great. I'm looking at the hub. I'm looking at your docs, and like you can tell there's just a lot of effort put into this. I mean, you're solving a hard problem with a ton of different data, and like documentation is just so important. Like I love the way that you actually define the schema. So I can look at the Okta provider right now, and I'm thinking, I wonder if I can actually do this. I can see the data you're pulling in and be able to like know whether you're going to support the use case I have or not, or whether I need to consider create an issue or try to extend that provider.
Yeah, exactly. Yeah. And like this is all up to date. So like every time, for example, like the Okta provider gets updated or the AWS, so the docs are kind of auto-populated. So a bit similar to Terraform registry in a sense, I think, and maybe also like Docker Hub. But yeah, I think Terraform registry is a good example, just like because they're dealing with very similar problem just from the provisioning side. So in some sense, like it's a very similar problem, and maybe like we have a bit easier life because we have only like the read problem and not the write problem, which is harder.
Sure. I want to talk about like just open source in general. Like you have this open source project, it looks like really good traction, like a good number of stars, like adoption of it. You've obviously been able to raise some money and create a company around it and focus on growing the team. There's a lot of open source projects out there that are also great, but maybe don't have that much visibility. So what advice can you tell us, or what stories can you share? How did you get to this many stars? Was it like a big reveal where you worked kind of behind the scenes and then open sourced the repo? Or was there a moment on Hacker News or Product Hunt or something else that really helped accelerate traction? Do you have any tips?
Yeah, sure. So I think in general, like stars is an awful metric for things. Mm-hmm. So yeah, like we got like the initial like star spike was from Hacker News. Yes, I had to post it like 5 times to relaunch it like 5 times until it got like to the front page. Wasn't able to do that. It's kind of like a hit or miss there. Mm-hmm. Like the first spike was just like visibility issue, and then I just actually did a lot of like small things, writing a lot about it. So it didn't solve like all my problems right away when I was still in the kind of like exploration phase. It was before we raised money. Like I was still trying to understand and talk to every CloudQuery user to understand, like, do we have a long-term users here, right? Or do we have like just, one Hacker News spike, right? So yeah, if you have one Hacker News spike, please don't go raise money, even if you can. I mean, it's not a good idea. So yeah, so for like 4 months, I was posting a lot of content and tutorials on Reddit, on Hacker News, and also just waiting to see if someone starts using it, right? Because if I put it on the Hacker News, like even if it's interesting for someone, maybe it's like not his top priority right now, right? Maybe it will be his priority in a month. So it was kind of like a drip of users from relatively medium to large to very large enterprises. I was talking to all of them, trying to understand like the use cases, trying to understand that they're going to use it like on a day-to-day basis. And kind of like only then I was like ready to double down on that and raise the seed funding, and then really continuing doing the same thing, right? It's like we still do that. We write a lot of content. We bring new users to the platform. We talk to all of them. We have monthly community hours. So yeah, like there is no one thing. You really have to like do this all the time.
Yeah, success by 1,000 cuts, as I like to say.
Exactly.
This is a little bit off, or we're going back to something you said, but you kind of mentioned something that I just wanted to ask you about. You were acquired by GitLab, you mentioned. And I know that they are pretty famous for their remote setup. And a lot of us are we're forced into a remote setup type world a while ago. And now we're all kind of adjusting to like maybe a hybrid. Maybe some people are staying remote. I just want to say, like, what are some of the big learnings and things that you learned over there?
Yeah. So one, I learned, I guess, that it seems to work, right? That it's not something crazy, that's like the first thing, that nothing completely breaks if you just do remote, right? And I think like some people are maybe aware or are scared of like that if they will go remote, like that's it. But before that, actually, I also worked remote for a lot of years, so it like wasn't completely new to me, but it still was nice to see it like work in a large enterprise. So like I learned that communication is super important, like written communication, Slack, Notion, those like pull requests, trying to be like as communicative as possible. This really helps. Time zones are also like quite important in remote. So if you have the luxury of like being more or less in the same time zone, like this will be helpful. But it really all depends on like what you can achieve, like what's your budget, where you can hire, right? So sometimes you can, you have to be flexible. So
sure. Yeah. Were there any particular like little things, little details that they did that kind of helped bring the team together, keep people on the same page? Anything specific that was just like, oh, we did a meeting every 13 days and that was super helpful? Or I don't know, just anything interesting there that.
Yeah. So I took probably a few things that I don't remember, probably all of them. So maybe like some of them I take for granted now. But one thing that I do remember that we also have in our company that I like to do. So in GitLab, you could schedule coffee chats, whenever you want with any other people just on the calendar. So I was doing that quite often, just with anyone in the company. You wanted to learn something or you wanted to meet someone new, you just put it there and people will take the meeting or will just say, oh, it doesn't work for me in this day, let's do it another day. So they were saying that this is okay to do. So it wasn't strange for people. So I think it kind of really helped. And I personally really liked it. I met a lot of new people this way, learn new things. It was a great opportunity. You have an opportunity to talk to any of 1,000 people in GitLab for free, right?
Totally.
Cool. So I want to kind of come back and think about going back to open source and kind of the ecosystem in general. You obviously work with cloud providers, not specifically Kubernetes. How close are you to the CNCF? Have you considered working more closely, even potentially making a contribution of a sandbox project? And then the last kind of question in this space is, there is Cloud Custodian in the sandbox right now, right? Which is an open source project that solves, at least on the surface, reading the docs, it sounds like a similar problem. And I'd love to hear your take on where CloudQuery shines versus Cloud Custodian and kind of some of the differences between the two projects.
Yeah, great question. So one on the Kubernetes, so we have a Kubernetes provider. It is still early on, and yeah, we want to invest more because we know we have a few users that use it, and we've been asked for a lot of improvements around that. And we know also it's a huge pain point. So it's definitely there's definitely more work around this integration on our roadmap. And for the CNCF sandbox, I think probably when we will get to it, I'll be more knowledgeable if it will make sense for us. And for now, I heard a couple of different suggestions and ideas from people that had more experience around that. And I'll be happy also to hear maybe your experience that a few folks told us, it's good when, I don't know, your users ask for that. But other than that, the overhead is too high. Some folks said that, it's worth it and it helped them. So kind of heard a few different opinions about that. So I don't have my own just because it's a bit too far from it. And with regards to Cloud Custodian, actually, it's a project I looked into even before we started CloudQuery because I was looking into the security space. And I was looking into is there anything open source alternative to all those enterprise companies? So I saw Cloud Custodian, but one of the big issues there when I tried to use it is that they focused on the end use case. So that you have to learn this DSL language for security. And they combined their ETL layer with the query layer. So, which is kind of make the project kind of only serve this use case while the number of use cases are actually infinite. So in my opinion, the idea was quite good, but the architecture, I think, wasn't the best because actually what you want to do is to separate those two completely different problems, hard but different problems. The one problem is to get all the data to a database, which is the first hard problem. And then actually the easier problem is then just to write rules on that. And also, I think writing rules in query language also from maintainer perspective and also from user perspective is much easier when you use a standard one, right? And you don't want, you don't need to implement a new one, right? So it's hard enough problem to solve the first one, the data engineering problem, that you probably don't want also to implement a query language if it's a solved problem.
Yeah, that makes sense. And thinking more about like the compliance and the policies and stuff like this, I'm wondering, like the use case very much makes sense, right? Like I totally understand it. We've recently gone through SOC 2 Type 2 compliance where, we have to generate reports for auditors. And some of that's like, like there may be a startup out there that's run for a while, has a lot of cloud infrastructure that they might not have their be able to like inventory really well. So CloudQuery is amazing in that scenario. It's also good just to start off for compliance. But like, I wonder now, like we talked like when we first started about, like the macroeconomic climate stuff is changing, in tech, and you have to like, one of the side effects is startups have to really become efficient, and you have to really think about managing costs more than you used to. Have you found use cases, or like, has there been any transitions or surprises where you see folks using CloudQuery to get a handle on like cloud cost more and more these days, or has that not really changed at all?
Yeah, I think the users that use CloudQuery even before that, I think were like aware of that. So I think it was like top priority for them also before that. Like something that we saw even before the climate change is quite a few big companies moving from or migrating from enterprise solutions to open source stack, just because it became so immensely complex and expensive in the last couple of years that they understood that actually it doesn't worth it anymore, and they can extend it to their own use cases, and it becomes like more work and more money than like they initially thought. So they were migrating to open source stack, to CloudQuery, or like to like considering other also projects in the space. So I think this is something that like I think, and probably I also hope that we will see more in the future.
Yeah. I mean, it goes back to the earlier conversation too, like I think you're doing a great job, and it sounds like, that move from proprietary software to open source solutions like CloudQuery makes perfect sense. I think that kind of speaks to the next step is where like the foundations, like, CNCF, Apache Foundation, things like this start to become like the next level of like continuity and longevity of the project, knowing that, while it's open source and there's a way that, if hopefully this never happens, but if, you as an organization like no longer are supporting the project, great, it's open source. I can throw some engineers on it and we can do what we need to do. But with that foundation ownership of the trademark, then there's more of like an open governance model. There's like other folks that like have expressed that they're also counting on it, and they can like, it gives those enterprises even like a more proven way to ensure that project's going to last.
Yeah, I think like that's probably the best point in favor of that, I think. But also I think like if you go to, and again, like this is something that probably I would also dig deeper and try to like get more data points when we'll get to that. So probably also like, for example, companies like Terraform, right? They are not in the CNCF, even though they have like successful. So you have like Confluent and you have like Apache projects. So you have like successful examples on both sides, right?
Yeah, and like on here, I think Benjie and I, neither of us are going to advocate, for or against it. I think it's just a really interesting thing to talk about and understand, why some people have taken projects really, really early and put them into a foundation, and some people, like to your point, Terraform it's an open source project, but like it's still owned by HashiCorp, and like the differences. It's interesting to have those conversations and understand the motivations behind it.
I mean, I think that the interesting thing that we're all kind of talking around is it used to be you never get fired for buying IBM. And now it's kind of like you're probably not going to get fired for buying using a pretty robust open source ecosystem and community. It's really weird how that's shifted. And now, obviously, IBM bought Red Hat, so I guess this analogy has just gone sideways. But I think it's really interesting, the shift in enterprise purchasing, where like open source is now something that is considered reliable and predictable. And then obviously you layer on these different foundations and governance, and you get some more stability and confidence there. And it just kind of speaks to Because it was not like that. I would even go, 6 years ago, 7 years ago, Mark? What would you say?
Yeah. I mean, I think, you still looked for that support contract, right? And now you're like, no, I need to take the future into my own hands, or ensure there's a path, at least for me to be able to do it. So
exactly. Yeah. So speaking of a path, anything interesting to share on the roadmap?
Yeah. So I can talk a little bit about some of the things that are coming. So one, we'll be looking into also adding more like database supports, right? I don't know exactly when, because like right now our focus is really around tooling, automation, and testing. And like the data problem, the most important thing is that the data that you extract it's coherent, right? You want to know that what you have in the database is your current configuration. You don't have like missing things or incorrect things. So this is something we put a lot of effort. But in terms of features, yeah, we're like thinking about supporting more databases, because like it's a data problem, and some, customers have different stacks. They build their like data analysis platform different ways. It's not always Postgres. Sometimes it's data lakes, data warehouse, things like BigQuery, Snowflake. So that's something that we'll be looking into. Another thing that is like not a feature per se, but more of like tutorials that we actually just like released and people asked for. And actually they even like built it in their own CloudQuery stack, but they asked for like concrete tutorials, and we thought it will be interesting to share with the community. So actually building like GraphQL layer on top of this data. So having GraphQL APIs. So we did it with a project called PostGraphile, if you know it. So it automatically generates GraphQL endpoint from your schema. So this was pretty useful for some of the users for kind of a search use case for their developer. Like the SRE team, for example, installed or deployed CloudQuery, and now they wanted to give like all the devs in the organization like a GraphQL UI to search for instances or IPs when they debug or develop something, and they don't have like access to all the accounts, or they don't even know where this IP or instance is located. So just using like a GraphQL UI is it's pretty neat. So this is something that we did recently.
Super cool.
Yeah, we'll include a link to that in the show notes here too.
Anything else on the FAR roadmap?
Yeah. So another thing that we were looking into is, or a problem that we heard from security teams or DevOps teams, is that like when they build their security guardrails, both for the infrastructure as deployed and for like infrastructure as code, they end up like writing the same rules for their infrastructure. Let's say if they have a CSPM or like whatever enterprise product, and then they write it in one query language, and then they write the same rules, let's say in things like OPA for Terraform or for CloudFormation in a different language. And then they have to like maintain it as we go. So something that we were looking into is giving teams the ability to write and maintain all the rules with one query language. And the idea around that was to integrate with things like Terraform or CloudFormation, right? Read the Terraform state and convert it, transform it to CloudQuery schema. So this will give security teams the ability to write and to run the CloudQuery policies, both on the infrastructure as deployed and on the infrastructure as code. And not only that, it will also open the door for things like detecting drift and doing all of that without writing code, right? Just by solving a data problem.
Wow, that's super cool. Well, Yevgeny, I think we're at time here, but I really just wanted to thank you for coming on, and we'll make sure to put a bunch of links in the show notes so they can find you, and really appreciate it. Thanks for coming on. Really excited to see where CloudQuery ends up going.
Awesome. Thanks, Benjie. Thanks, Mark. Really, really enjoyed it here. It was great chatting with you.
That's all we have time for today. If you're interested in being a guest on this show, or if you would like to suggest a topic, head over to Kubelist.com. I'm Marc Campbell, CTO at Replicated, where we enable cloud-native software vendors to operationalize and scale the distribution of their modern on-prem applications to their largest enterprise customers. Check us out at Replicated.com. My co-host is Benjie DeGroot, CEO at Shipyard, where they enable isolated ephemeral environments on every code change for companies of all sizes. Check them out at shipyard.build. This show is brought to you by Heavybit, the leading investor in developer-first startups. For more information, visit heavybit.com. And finally, don't forget to sign up for the Kubelist weekly newsletter and read previous issues at kubelist.com.